G'day viewers, this is Troy from Troy's Visual Arts channel. I've been doing some work on building the high tension power supply for the high tension section of my Iconoscope camera tube. Basically this is the pictorial diagram of how the power supply is laid out, minus the inverter of course, but we'll get to that shortly. But anyway, basically I'm using a transformer which is a dual output transformer, 15 volts. And it's also got 12 volts output as well, dual 12 volts. I've connected the 0 volts together to make it a dual power supply, make it a center tap. Anyway, I've got that connected to my plus minus 15 volt dual supply, just seen on the diagram, which is connected to a 1 kilovolt minus 1 kilovolt power supply, which requires plus and minus volts to operate. Anyhow, as the Iconoscope tube, I'll get to the spec sheet of the 1848, which is similar to the 1846, which is one we're going to be using. Seeing that the 1848's operating requirements is plus 1000 volts for both the NO2 and the grid 2, I have to somehow invert the minus 1 kilovolt voltage to make it plus 1 kilovolt. So I've put in there a block for an inverter, which I'm going to have to source on the internet information on building one. Anyway, and basically I need to tap out about 300 to 400 volts to go to the anode 1 of the Iconoscope tube. So I've devised a voltage division of 13 megohms and 7 megohms, and I'll tap 350 volts out from there. So I've got several resistors connected series parallel to make that voltage division. Anyway, this power supply is working. It's outputting minus 1 kilovolts. Just to show you, I've got the meter connected to the output. Now I've adjusted it down to to get minus 460 volts, so it's within the meter's readout range because it doesn't go up to 1 kilovolt. But anyway, I'll power her up, and yeah, I've got set to minus 468 volts. And just to prove that the ratio is within accuracy, here we've got the readout, which is about 100th of the output readouts. So this part here, 1 volt equals 1 kilovolt. So set it down to 2 volts, power it up, and we get about minus 0.461. So times that by 100, you get 4, or times that by 1000 actually, you get 461 volts. Anyway, so it's pretty well accurate, this power supply unit. It's a very nicely designed power supply, kindly donated to me by one of my tech friends. Anyway, now there is just one problem though. I was told that yeah, the Iconoscope tube takes about 50 microamps, but I found on the spec sheet it actually takes a maximum of 0.5 microamps, so I'm going to have to get an even greater set of resistances there in order to down the microamp amount of current going through to under 0.5 microamps. I'm going to double check with my tech friend to find out a little bit more, because I'm a little bit confused. It's pretty damn low amount of current, eh? You think back in the early 40s they'd be, you know, dealing with nanoamps and all that. Anyway, I mean back then, you know, quite back then you'd think they'd be dealing with higher amps than what they do today, which today, you know, you go to the nano amps, pico amps and whatever. Anyway, better get back on track here. Now, so basically, yeah, I'm getting 1 kilovolt output. I'll power it back up again. I want to get about 1 kilovolt, so we'll jack it up till we get, jack the pot up till we get about 1 kilovolts. Yeah, about that. 1024 volts. Power it down. Now I'm going to connect the circuit in. Now I've got here a DC microamp meter. So in there we've got roughly something over 20 megohms of resistance, and I'll be tapping the 350 volts off this resistor here. But anyway, power it up. The microamp meter goes off the scale. We're supposed to get about 50 microamps, but yeah, in theory yes, but in practice things can get a bit different. But yeah, I've got something probably between 50 and 100 microamps in current going through this circuit here on the high tension outputs. But of course, yeah, I'm going to have to down it to something under 0.5 microamps, going by the spec sheet there. But anyway, yep, we've got 50 over 50 microamps output. Now, I want to test the voltage output here, but unfortunately, because this meter is about in the hundreds of kilo ohms of resistance, I'm unable to do so. So I'm not going to get an accurate output, because basically I'm basically got the meter connected between that tapped output and ground. I'm getting a lower current going through now, and I'm getting a voltage drop of minus 60 volts, which I should be getting minus 350 volts. But that's because yeah, the resistance in this voltmeter section would be within, I'd say, in the 200-300 kilo ohm range. I'm taking a guess, going off memory from what I've studied. So I'll take that meter off, and yeah. So basically, yeah, we've got very high resistance here, and putting, you know, a few hundred kilo ohms of resistance between the tapped output and ground, that will lower the resistance from about 7 megohms to, yeah, something under 300 kilo ohms. That's just guesswork. So yeah, I can't test the output, which is a bit of a drag. Anyway, but yeah, hypothetically we should get something between 300 and 400 volts at that tapped output, going by the voltage divider rule there. So it should be all good. But anyway, pretty much got me high voltage section set up roughly. Now all I have to do is yeah, put an inverter circuit at the high tension output, and yeah, as I've mentioned for the upteenth time, I'm going to have to lower the output current to something under 0.5 microamps. Anyway, that's the status of me high voltage section. It's near done, to my personal opinion. Anyway, nothing much more to say. Stay tuned for the next video, which I'll talk about me head amp that I've made based off a Plumicon tube head amp circuit. This is Troy from Troy's Visual Arts channel, signing out.